Hi everyone, this is Mr. Cardoso, and in this video lesson on our continuing introduction to objects, we are going to talk about the keyword static. What does that mean? We've seen static from the beginning of since we started learning about Java. We started doing our Java programs at the very beginning in a method called public static void main, and that's when we hit the run button up here. That's what Java looks for and starts running. So you see static in there, and you also see static in any of the methods that we've previously learned before we got into objects. So all of those methods in the last unit had the keyword static in it. So what exactly does the word static mean? And that's what we're going to talk about in today's lesson. So in the fraction class, as we have here, this is the example that we've been using throughout all of our lessons. In our fraction, this is our object class, so this fraction class defines what a fraction has with a numerator and the denominator as integers. We have our constructor, and then we have what we call our instance methods. And we say this is what the object can do. These are the verbs. So for example, a fraction has a numerator and a denominator, which are both integers. They're created like this with these constructors, with either nothing in them, or they can be created by passing a numerator and denominator to initialize the fields. And then these are all of the things that a fraction can do. So we can check if they're equal to another fraction. We can set the denominator and so on and so forth. We can multiply times. So these are all the instance methods. And because they're instance methods, they're applying to an instance of the fraction class, right? So that is the difference. So let's just go over that a couple of times. So here we're in our fraction calculator class, and if you recall, this is our class that our secondary programmer would use to then use and manipulate fractions, or maybe that's just part of a bigger program or whatever. So let's go fraction f1 equals new fraction. Let's create a new fraction, 3/5. And now we can then do something like this, system.out.println, and say f1.toDecimal. So that's how we call a method, an instance method. f1 is an instance of the fraction class. This is just our variable name, right? We could have called it whatever we wanted, but it is of type fraction. And to call an instance method like toDecimal, we have to use an instance of that method, of that class. So f1 is an instance of that class, so f1.toDecimal. Compile that and run that, and we should get 0.6 printing out, which is 3/5. So that's what toDecimal does. So we can make another fraction called f2 and make this one 1/2, for example, and then we can copy and paste this and call that toDecimal instance method now on f2. And that's why it's called an instance method. So f1 and f2 are both instances. And so we get our method operating on two different instances of the of the fraction class. So these have to be instances. Okay, now let's just take a look at that example, the toDecimal, and let's write it slightly differently. First of all, let's find it. toDecimal, here we go. Now, what we're going to do is we're going to put the keyword static in there. So we're going to go public static double, so just like the last unit, toDecimal. Now, because we put the keyword static in there, that means that this method, and by the way, I could write this method anywhere, this is actually called a class method, not an instance method. So maybe I should put them at the bottom just to organize it. I said these are all instance methods up here. So let's just say, these are our class methods. You can organize it. Actually, you know what? I might want to keep it up there just so we can compare them. But yeah, in a real program, you organize, you usually keep your class methods kind of together. But again, there's different ways of organizing it. There's no hard and fast rule on that. So let me find that 2 decimal again. Oh, it escapes. Okay, so this is our class method. And because it has the keyword static in it. Now, why is it called class method if it has the word static in it? It has to do with the way we call the method. Okay, so now we're not calling it on a particular instance, right? This one is calling it on instance, so this is instance method version. And this one is the class method version. And so basically we're going to do this here. Let's copy and paste that line of code. The problem is here, if we try to compile this, right, it says, first of all, there's 2 problems here, right? The first problem is there's 2 methods called 2 decimal. And then if you recall from the last chapter, we talked about method overloading. So you're allowed to have 2 methods of the same name called 2 decimal as long as the parameter list is different. But the parameter lists here are the same. So that's a problem. The other issue here is because we have the keyword static in here, we don't know what this is. It means that we can no longer access the implicit fraction. The implicit fraction does not exist inside this method. So this makes no sense. It has no, and you can say cannot use this in a static context. So we've got the word static in here. It's a class method, which means we can't access the implicit method. So we're going to have to change this. In fact, if we can't, the implicit object. So if we can't access the implicit object, we're going to have to take that one in. So we can call that fraction f, for example. And that actually solves 2 problems. Because now we have 2 methods with the same name, but now the parameter list is different. So now we can use the ideas behind method overloading. And now we should be able to eliminate that problem. Now we're using fraction f. So here we can go f dot num divided by f dot den. We have the cast in there to make sure that we get close here. So to make sure that we can get the non-integer division. So that's why that's there. So let's give that a shot now. Let's try to compile that. And now that works. So we've got 2 different methods that do the same thing, and they have to be called in different ways. So let's go to the fraction calculator, and let's see how you would have to call the second 2 decimal version. So we've already seen this one up here. So if you wanted to call the second version, system.out.println, you actually have to use the class name. So you can go f1.2decimal, or you could, but that would call the instance method version, right? So the one that we want to call is the class method version. So what do you think we use? We in fact use the class name. The class name is fraction. Go way up to the top. The name of the class is fraction. So we use the class name, so fraction dot, and then the method name, so 2 decimal, just like we would in the last unit. Before we even got into objects, it's the exact same thing. If the method was not in your current class, you would have to use the class name to access it, as long as, again, it's not an instance method. And now here we need to send something in the parameters. We need to send a fraction. So for example, we can send f1 or f2 or any instance of the fraction class. So now if we print this, this should print out, and let me just make a little message here. The class method version, so it's different. Compile that, and then hit the run button. And you can see we're getting the same 0.6. Okay, but the way you call it is different, right? We have to go class name, then method name, And then because we're not sending in the instance here, like so over here, for example, look very carefully at this versus this. Okay, here, there's no static in this version of 2-decimal, if you remember. So it's an instance method. It means an instance must come before the dot. So F1 and F2 are both instances. So the instance must come before the dot. So we go F1.2-decimal. And in this case, there's nothing in the brackets because 2-decimal only requires one fraction. And we're going to find the implicit fraction and then convert that to a decimal. On the other hand, down here, this version of 2-decimal has the keyword static in it. So that means it's a class method. And why do we call it class method? To answer that question, because we use the class name to access that method. So the name of the class is fraction. So notice fraction is not an instance of the fraction class. Fraction is the fraction class. You know, F1, F2, Stefan's fraction, for example. That if you name this Stefan's fraction, those are instances of the fraction class. But this fraction, that's actually the class name. So we go class name dot method name and then the parameter. This time, because we need to find a decimal version of a fraction, we need one fraction. So in this case, the only way to do that is to send it in. Okay, you can do that with a whole bunch of these fractions. A whole bunch of these methods. So for example, we can go to the times method and we could make, I'm not going to do the whole thing, but we could go public static fraction times. And now because it has the keyword static in it, we cannot access this implicit fraction. So that means if we're going to multiply two fractions, we need to take in two fractions. So we can say fraction F1, fraction F2. Again, these are local variable names. They have nothing to do with the F1 and F2 that were declared in the other class by another programmer. Okay, and you can do basically this whole thing, but you would have to change this to F1, this to F1, and other to F2, and other to F2. And then how you would call that over here is you could say, you could put it in system.out.println, or we can make another fraction called result, and you would say fraction dot times, and then you could go F1, F2, which would get mapped in, or we could even do F2 and F1 just to show you that they have nothing to do with those variable names. So F2 would actually get mapped into F1 over there, and F1 would get mapped into F2, because the order is the thing that matters here in these method calls. But yeah, that's how you would call it. As opposed to the other way you would call it, which would be fraction result equals F1 dot times F2. So this would be instance method version call. And this over here would be class method version call. And this one, this method has static in it. Okay, so your next question should be, hopefully, when do you use what? And since you can do both, well, which one seems easier? And since Java is an object-oriented language from the start, most things in Java, in fact, are objects. We haven't been dealing with them for like a year and a half, but most things in Java, in fact, are objects. So that's why the simpler version doesn't have the word static in it, because that's more natural. And notice how it's like a lot shorter. It makes a lot more sense to call it on an instance if you are actually changing or using that implicit instance of the fraction class to, modify or change. Then yeah, why not work with that instance method? Generally, we use static or class methods when we are usually not doing anything to be involved with any of the instances. So I wouldn't do times and 2-decimal in this static or class version. Maybe something that has nothing to do with the instances of the fraction class at all, but maybe something to do with setting the number of decimal places or something like that doesn't exactly operate on the implicit instance or another instance of the fraction class at all. Then you can use the static or class method version. Hope that makes sense. Catch you next time.